Okay, we are going to now do the limiting reactant percent yield in class activity notes. And so you would start off by asking yourself, how do I recognize a limiting reactant problem? Well, in a limiting reactant problem, you're going to have specific amounts of more than one reactant. That is, nothing is in excess, and so you'll have specific amounts. So here's my reaction, and it looks like I have 4.2 grams of calcium, and I have 2.80 grams of oxygen gas. So that's 4.20 grams of calcium and 2.80 grams of oxygen. I don't know which one will run out. It's a 2-to-1 ratio, but they have different molar masses, so I have to figure that out. And the way that I figure out is that I convert grams to moles. That will be step one after you've recognized that you actually have a limiting reactant problem. So this will be X moles of calcium. I've got 4.20 grams of calcium. I'm going to convert grams to moles by dividing by the molar mass. The molar mass of calcium is 40.08 grams for every 1 mole of calcium. And when I do that, I'm actually going to get the number of moles of calcium that I have to work with. But then there is another step to determine which one is the limiting reactant. I need to divide by their respective coefficients. The coefficient of calcium is 2. And so then you're going to get another number. Okay? And so let's go ahead and do that. So that's 4.2 divided by 40.08. And that gives me 0.10, and I'm gonna keep an extra sig fig just for grins. 0.1048. 1048 moles. There's a decimal sitting right there. And then I'm going to divide that by 2, which gives me 0.0524. Okay, 0.0524 moles. Let me clean that up a little bit. What a mess. Okay, it's getting late again. Tired. So here we go. That's 0.524. 0.524. Okay, that's good for calcium. Let's go ahead and let's scroll on down and figure out how many moles of O2 that I have to work with. Let's get a pen. Okay, let's figure out how many moles of oxygen we have to work with. We've got 2.80 grams of oxygen. We'll go ahead, divide by the molar mass of diatomic oxygen, which is 2 times 16, which is 32 grams per mole of O2. That's going to give us a number in moles. We have to look up, find the coefficient from the balanced chemical equation. It's 1, so we're going to be dividing by 1, and then we'll get some number of moles of O2. So let's do that. So that's 2.8 divided by 32, which gives me 0.0875. 0.0875 moles divided by 1, which is 0.0875 moles. So it looks like calcium, which is 0.524 moles, compared to 0.875 moles, this will be our limiting reactant. So we don't need to worry about O2. It exists in excess in this particular problem. Okay, let's go ahead and figure out how many grams of calcium oxide that we can produce. And we've already done half the work by turning up what we have. We have 0.524 moles of our limiting reactant, which is calcium. And so here's all I actually have to do. All I have to do is multiply by the coefficient of calcium oxide, because to get the 0.0524, I've already divided by the coefficient of calcium. So this is just going to be 2 times the molar mass of calcium oxide. Let's go ahead and figure that out. So calcium is 40.08 grams per mole. Oxygen is 16. So let's see what we get. So that's 56.08. So we've got 56.08 grams per mole for calcium oxide. So that's all I'm going to do. Plug that right here. Grams per mole. Okay? And that's just the molar mass. So this is the coefficient of calcium oxide. This is the molar mass of calcium oxide. So 0.0524 times 2 times 56.08. And that gives me 5.88 grams. So I've got 5.88 grams of calcium oxide. Now, the gram to gram method, which is a little inefficient, but let me just go ahead and employ that so I can show you that this method up here works. So I started out with 4.20 grams of calcium, my limiting reactant. I divided by the molar mass, 40.08 grams for every 1 mole of calcium. I did the mole to mole ratio, which said it requires 2 moles of calcium to produce 2 moles of calcium oxide, and then every 1 mole of calcium oxide weighs 56.08 grams. Now, this is just doing the entire problem of gram to gram stoichiometry over again. The top method was taking advantage of the fact that we had already done this much work. Okay, by getting to the 0.0524, that's 4.2 divided by 40 divided by 2. What we did up here is the top half, which is just 2 times the molar mass. So if I do this again, we've got 4.20 divided by 40.08 times 2 divided by 2 times 56.08, and that gives me exactly the same answer, which is 5.88 grams of calcium oxide. It is up to you whether you want to, once you determine the limiting reactant, go back and do everything from grams of your limiting reactant to grams of your product. But in this case, if you're comfortable, once you've determined your limiting reactant, converted grams to moles, divided by the coefficient, this is where you are. You're already halfway home. All you have to do is multiply by the coefficient of your target, and which will be one of your products, and then times the molar mass, and you're good to go. All right, determine the mass of the excess reactant that will react with the limiting reactant. Okay, so here we go. This case, we're just going to figure out how many grams of O2 we're going to use up. Okay, and we still use our limiting reactant, 4.20 grams. This is calcium. And then we've got 40.08 grams for every 1 mole of calcium. And then it takes 2 moles of calcium to react with 1 mole of oxygen, and then 1 mole, and this is O2, not O, and 1 mole of O2 weighs 32.0 grams. Okay, so here we go. Grams of calcium will cancel. Moles of calcium will cancel. Moles of O2 will cancel. So that'll be 4.2 divided by 40.08 divided by 2 times 32. So that's going to be 1.68 grams that we're going to use. 1.68 grams of O2 that we used. Okay, now I want to know how much is left over. Well, we started out with 2.80 grams of O2. We're going to subtract the 1.68, so 2.8 minus the 1.68, and that gives us 1.12 grams remaining. So I have 1.12 grams of O2 remaining. Okay, that's how much is left over. Okay. So now we're just going to do a simple percent yield calculation. Determine the percent yield of calcium oxide if a student was able to isolate 4.76 grams of calcium oxide in the lab. No problem, because you want to remember that percent yield is simply what you get in the lab, which we call the actual yield, divided by, that somehow spells yield, divided by the theoretical yield, and then multiplied by 100. We're just asking ourselves, how efficient is our reaction? How good is it? Remember that the actual yield is going to be the smaller amount. It's what comes out of the lab. The theoretical yield, that is what you calculate, okay? And we did the calculation. Now, if we look up here at what we calculated for our theoretical yield, it is 5.88 grams of calcium oxide. Oops. So, here we go. So, my percent yield equals 4.76 grams divided by 5.88 grams times 100. Okay, so 4.76 divided by 5.88 times 100, and I got a percent yield of, I'm going to call it, it's 80.95. I'm going to go ahead and call it 81%. I'm going to say it's 81.0% yield. Okay, I think that should put you in line to work the rest of these. They all seem to be headed kind of in the same place. Yeah, I think we're good, kids. And that's good practice for the test. So I would highly recommend, even though this is not due, I would highly recommend that you do this activity as well. I've put it in the modules, and so it's available for you to work. Okay? All right, here we go.